Hi everybody, welcome back to algebra. So we did 8.1 and 8.2, which was just some introduction to quadratic functions. We are now ready to graph quadratic functions. We are graphing without a graphing calculator at this time. You will all receive your graphing calculators and you'll be able to use them, but everyone should know how to do this without a calculator. You never know if the test you're taking is going to provide a calculator online. So you need to know how to do it the hard way, the long way, whatever you want to call it, and then verify using the graphing calculator when you get it in your hands. So let's start graphing quadratic functions. Y equals x squared minus 4x minus 5. We know that the quadratic needs to have that square there. Find the axis of symmetry. That's the first thing we do. In our last section, we learned this shortcut formula, the inverse of b over 2a. Now remember, this is like saying a squared minus 4b minus c. So your b is coming right here, the center x, and your a is the x squared. I probably should have gone ahead and let's just make this a squared. No, actually I don't want to do that because I want you to realize that when we start plugging in a value for x, that's where you have to put it in. So if you solve this short formula, you get that x equals 2. Now you can go ahead and plug 2 into the equation where x is, and you can solve for y. This gives you not only your axis of symmetry, which is the dashed line, but you're also going to get the vertex of your parabola. Remember that the coefficient of x squared is going to tell you whether your parabola opens upward or downward, so that you know which way it's going, whether you have a maximum or a minimum. In this case, x equals 2, and the vertex equals 2 comma negative 9. Find the y-intercept. That's when x equals 0. When x is 0 and the parabola crosses the y-axis. The y-intercept is still the constant c. So y equals x squared minus 4x minus 5. The y-intercept becomes a point on the parabola. The y-intercept is negative 5, and the coordinates of it are, of course, x is 0, y is negative 5. So using this same information, I'm on to step 4. Choose 2 values for x that are on the same side of the axis of symmetry of the parabola that the y-intercept was on. So let's look at this. 2 values for x that are on the same side of the axis of symmetry. Here's my axis of symmetry, this green dashed line, x equals 2. Now I want to know where is my y-intercept. It's on the left. It's right here, 0 comma negative 5 was my y-intercept. My vertex was 2, negative 9. I know that my parabola is going to point up, open upward. They say pick any 2 x values on the same side as the y-intercept. So anything to the left of x equals 2. I choose x equals 1 and x equals negative 1. I solve my formula by substituting in a value for x, and I get 2 more sets of coordinates. And I am able to extend my parabola line. Sorry for all that crookedness, but I don't have a way to get a steady hand and do that with my computer. Step 5, graph the axis of symmetry, graph the vertex, graph the y-intercept, and graph the 2 points that you just added, the positive 1x and the negative 1x. Look how nice my line is getting, much better. I now have one side of my parabola. How do I get the other side? It is a mirror image. Hence the word line of symmetry. Axis of symmetry means if I fold my paper over on that dashed line, I can duplicate the right-hand side. I also can do something like count the actual spaces, count how many units are to the left, make the same number of units to the right, and put in my data points, and I can complete my parabola. Yes, a lot of work, all done by hand, but that's okay, because everyone should know how to do it by hand first. In this case, my domain, my set of x values is all real numbers. That's almost every 99% of the time, my domain is all real numbers. Y, my range. Y starts here at -9 and goes up, so it's equal to or greater than -9. Vertex, 2, -9. Axis of symmetry, +2. Practice. Now, in order for you to do number 12, you have to rewrite the equation first. You have to isolate y. So you need to move that -1 over to the right before you can even begin. Same thing will happen with 1b. You can't have that 6x there. You have to move it to the other side. Let me show you practice number 12. All right, that's a lot of happening on this page. I understand that. So let's start slow because there is a lot of information for me to show you when you do this by hand. So I start here on the left in purple. Y minus 1 equals 4x squared plus 8x. I added the 1 to both sides. I now have my quadratic. I use my formula inverse of b over 2a, and I find out that my axis of symmetry is x equals -1, and I plot my axis of symmetry. Using my axis of symmetry, that gives me another set of coordinates, which I'm going to go ahead and plug in x equals -1 into my equation, and I'm going to get a y value of -3. I now have my vertex, -1, -3. Go back and make sure you understand that. I plugged in my axis of symmetry as a possible x value, just like having an xy table. And I solved for y, and I graphed that point. That is my vertex. I know it opens upward because my coefficient of x squared is positive. Here I say, well, what if I choose a value on the same side of my axis of symmetry? I choose 1, solve for y, and I get 13. When x is 0, y is 1. So I also found my y-intercept. Now I can just mirror my data, and I will get my complete parabola. If I'm going too fast, I apologize. Please go back and take a really good look at this. You will find that these are also online in your drive for you to look at these slides one by one. Although I think this one was handwritten and I retyped it just for this video. Here was the second example. Y plus 6x equals x squared plus 9. I need to move over the 6x. Perfect. You calculate my axis of symmetry, inverse of b over 2a, graph it. Go ahead and use that x value, plug it in and get a y, and I get my vertex. Once I have my vertex and my axis of symmetry, now I can replace x with any value and solve for y to graph coordinates. So just pick x values. I pick 4. X is 4, y is 1. I can go ahead and just keep picking values, and then I mirror them on the other side. My vertex is 3, 0, an axis of 3, domain all real numbers, y is greater than or less than 0. Now, you're going to get a lot of questions about this, and I used to skip it. but it is on the algebra exit exam usually. It is on the NWEA. It is part of algebra. So I think it's important. The same way quadratics are on the algebra exit exam. Linears are on it. This is something, how you calculate how long it takes for an item to fall or the height of an item when it's up in the air. The quadratic function h of t equals negative 16 t squared plus c. That formula can be used to approximate the height in feet above the ground of a falling object t seconds after it is dropped from a height of c feet. The model is only approximate because it does not allow for air resistance, wind, other real-world factors. We are just doing a basic formula. You will need to solve for the original height, which is your constant. Nothing to solve. It just is your constant. And then you will need to solve for your zeros to determine the time. The zeros are when the object hits the ground. If an object is falling, the parabola is facing downward. So you learned in your other videos how to calculate your zeros. You'll need to go back and be able to do that. Let me take a look real quick also at 8-4. Oh, I don't want to start at the beginning. Here we go. Transforming quadratic parabolas. Actually, I'm going to wait. I'm sorry. I'm going to make this a separate video. Sorry.